Let us try to solve the second numerical in Thevenin's theorem. So second problem. So the problem given is find the amount of load current across 1 ohm resistor using Thevenin's theorem. Okay, so he is giving like this. So we have an current source and we have an resistor, we have a resistor and a voltage source, 10 volts, 2 amperes, 10 ohms, and you have one more 5 ohm resistor, and you have 1 ohm, where this is the RL given in the problem, which is nothing but 1 ohm. Okay, this is 5 ohm, and he is asking us to find out the load current across 1 ohm resistor using Thevenin's theorem. So we are clear that, so we want to draw the equivalent circuit of Thevenin's theorem. We have an first step is finding out open circuit voltage, second step is finding out Thevenin's resistance, and remove the load resistor. Already removed, no? So the removed load resistor is how much? RL is equal to 1 ohm. So I need to find out the IL. So this is the equivalent circuit of an Thevenin's theorem. So how to find out IL here? So IL is equal to, so the current is going like this. What is the leaving polarity of the voltage? So this VL, current is leaving. What is the leaving polarity? Plus VL. So VL minus VL, so my hyper VL minus 0 divided by the current is flowing. I can say these two branches are connected in which connection? Series connection, divided by the branch resistor is R Thevenin plus RL. So you are going to get, we need to find out this 1 as well as 2, where this is called VL or VOC, open circuit voltage. So coming to the first step of solving, we need to find out open circuit voltage. So how to find out the open circuit voltage? First remove the load resistor as it is. Okay, so I am drawing a current source. This is 2 amperes, this is 10 ohms, this is 10 volts, this is 5 ohm, and we have been removed the load resistor. So when you remove the load resistor, this will be an open circuit voltage, and this voltage will act as an open circuit voltage. So the voltage at this point and the voltage at this point both are same, which is nothing but VOC and 0 volts, and the same voltage is also available here, VOC and 0 volts. Now we want to find out VOC. You can see here I am going to apply the nodal analysis at this point. Okay, so in this nodal analysis, so one entering current is there. I am assuming this as one leaving current in this branch, and next this is also one leaving current which flows in this direction. So apply nodal analysis at VOC node. You apply the nodal analysis to this node. But how many entering currents are there? So only one current is entering. What is that entering current? 2 amperes current is entering. And what are the leaving currents? This is, we determine this current as I1 and this current as I2. So 2 is equal to, how to write down the current I1? So current is leaving. What is the leaving polarity of the voltage? VOC minus, current is coming like this. What is this leaving polarity? Minus, VOC minus 10 divided by, what is the branch resistance? 10 ohms, plus how to write down the current I2? So this is the current I2 flowing. How to write down this? VOC minus 0 divided by, what is the resistance of this branch? 5 ohm. So from here you can find out the VOC value. So that is equal to 2 is equal to VOC of 1 by 10 plus 1 by 5, so minus 1. So you separate these terms, then you are going to get the VOC is equal to 10 volts. So you got VOC as 10 volts. The first step is completed. So coming to the second step, which is nothing but finding out RThevenin. So how to find out RThevenin? Let us try to see here. So how to find out RThevenin? So the procedure of finding RThevenin is very simple. So remove the load resistor. So we have already removed the load resistor, and this. So remove this load resistor and replace the. So you can see all the sources given are independent sources. So voltage source you have to replace with short circuit, and current source you have to replace with open circuit. So if you redraw this network here, so it will be like this. Okay, so when you are going to redraw it, it will be assembled like this. So this current source you are making like an open circuit. So this current source we are making like an open circuit, and we have an resistance here, and here you are going to have an voltage source. This 10 volts we have been short circuited, and this current source we have been open circuited, and this is continued like this, and you are going to have one more resistor where this value is 5 ohm, and at this point we need to find out looking from the load side, we have to find out RThevenin. So how to find out? So this value is 10 ohm. So see here, the current is entering, current flows in 5 ohm and current flows in 10 ohm, and the current what comes, it flows. See here, the current what comes here, it will flow only in 10 ohm. It doesn't flow here. Why? Because this is already open circuited. The current in this branch is 0, therefore current doesn't flow. So how the current flows? The current will start flowing into this node and it will get diverted here. You can see here these two are connected in series. Okay, so now when you consider these two with respect to these two branches, here the current doesn't divides and it directly flows, and this is one resistor and this is another resistor. So let's try to mark if you are having any confusion. So 1 and 2, how many resistors are there? 2 resistors are there. So the current starts flowing like this, and current is going to divide. When the current is dividing, you can say that these two are connected. Which connection? Parallel connection. Are connected in parallel connection. So what is the parallel combination between 1 and 2? So this is 1 is 5 ohm, 1 is 10 ohm. Product of resistance divided by sum of resistor, which is nothing but 50 divided by 15. You are going to get it as a 3.3 ohm. Where this is a R internal, or where this is called the Thevenin resistance. So you replace with the original circuit what we had already analyzed. So when you replace this, VOC is equal to 10 volts, and here we got this Thevenin as 3.3 ohms. So this is nothing but 10 minus 0 divided by R Thevenin is 3.3, and load is 1. So when you are going to perform it, you are going to get 2.325 amperes is your answer. Let's try to recall the problem, those are unable to understand. See here, this is the problem given, and we want to find out the current in this branch. So first step is remove the load and find out the open circuit voltage. The voltage at this point and the voltage at this point both are same, and to this node we are going to apply the nodal analysis. When you apply the nodal analysis, one current is entering. So what is entering current? 2 amperes is entering, leaving currents is I1 and I2. So how to express? VOC minus 10 by 10, VOC minus 0 by 5. So from this step you can calculate the VOC value. Second step is calculating the Thevenins. So how to calculate the Thevenins? So current sources should be open circuited, voltage sources should be short circuited, that's why it is short circuited. Here you have 10 ohm and here you have 5 ohm. So the current will start like this and the current will not divide in this branch. So this will come like this and it will flow only like this. I can say the current enters, the current divides only between 5 ohm and 10 ohm. I can say 5 and 10 are connected in parallel. So when you apply the parallel formula, you got this Thevenin resistor automatically. You can substitute in your formula 10 divided by R Thevenin is at 3.3 and RL is 1. You are going to get the answer as 2.32. So this is not like just by listening the class you'll get the concept. So write down the given problem and solve it and verify with the answer, then you can understand better. So this is how to solve a problem on Thevenin's resistance. Now let us try to solve one more problem on this network. For the circuit shown below, find the for the for the circuit shown below, find the current across a load resistor, which is nothing but 5 ohm. So using Thevenin's theorem, so we want to find out the current across this branch. So the given network is like this. So you have an 1 ohm resistor, you have an 2 ohm resistor, you have an voltage source, and you have an 5 ohm resistor, 5 ohm resistor. You have an 5 ohm resistor, and a current source is connected in parallel to this. So you have an current source of 2 amperes connected in between this. So you have an 2 ohm source and 1 ohm source. So this is the load resistor given to us. Let's try to find out the current across 5 ohm. So in this branch we need to find out the load current IL. So how to find out the load current IL? So the process here of finding out IL is, first step, already we are very clear with the process. So first we have to find out, draw the equivalent circuit. So this is nothing but open circuit voltage. Second step, we find out Thevenin's resistance, and this is the RL given in the problem. So we want to find out this IL. So the voltage at this point is VOC. The voltage at this point is 0 volts. So how to find out IL? So IL is equal to, so current is leaving, what is the leaving polarity of the voltage, plus VOC, current flows in R Thevenin and current flows across RL. So VOC minus 0 divided by, so these two resistors are connected in series, which is R Thevenin plus RL. So this is the formula, just substitute this by using here. So taking this network, first one is finding out the open circuit voltage. How to find the open circuit voltage? So you see, redraw the network. So you have an 1 ohm resistor, you have an 2 ohm resistor, and the load is open. And if you have any confusion, this is of 0 you mark, this is as 1 you mark. Between 1 and 0 you have an current source like this which goes down. So this is 0 and this is 1. So we need to find out the voltage VOC. So this is of 1 ohm. Okay, so let's try to reduce it. So I'm going to apply source transformation. So this is an practical current source. Convert this into an practical voltage source. When you convert into a practical voltage source, so between 1 as well as 0. Between 1 and 0, you can see here. So you have one resistor, this is 1 ohm, and the current is flowing down. So this will be a negative terminal, this will be an positive terminal. So V is equal to I into R. Current I is equal to how much it is given in the problem. So this is 2 amperes and the resistance is 1 ampere. So this will constitute a voltage of 2 volts, and you have a 2 ohm resistor, and you have an voltage source which is nothing but open circuit voltage. So now we need to find out this voltage. You see here, so this is of 4 volts. So this is one voltage, this is one voltage, and we have find out this voltage. And now we need to find out how much amount of voltage. So let's try to mark the current is flowing like this. So this is plus, apply the Kirchhoff's voltage law. Current is leaving, what is the leaving polarity? Plus VOC, and current is flowing like this. What is the leaving polarity? Minus 4, and coming to here, the leaving polarity is how much? Minus 2. So when you solve it, you are going to get it as a, so this is minus 4, and current is leaving here, this is plus 2, and VOC you are going to get it as 2 volts. So this is one step we have been completed. So VOC you got it as 2 volts. Now the second step is finding out the Thevenin's resistance. So how to find out the Thevenin's resistance? See the network, you can understand how to analyze it. So for this circuit, you have to find out. So you can see here, this is an current source with a current of 2 amperes. So what we can perform is, the current source is independent sources, the current source is open circuited, and you have a resistor of, this is 1 ohm, and you have an resistor of 2 ohm, and this voltage source is short circuited, and now this is R Thevenin. And this is R Thevenin. So when you see here, the current will start flowing into 2 ohm, and the same current will flow. I can say these two are connected in, so this 2 ohm and 1 ohm are connected in series. So therefore the resultant we are going to get like this, and where this value is called Thevenin's resistance, and this is 2 plus 1, this will constitute approximately 3 ohm. So already as per the formula we substituted, this is of 3 ohm. So open circuit voltage you got 2 minus 0 divided by Thevenin's is 3. So Thevenin resistor you have been got as a 3 plus 5. Okay, so 3 plus 5, we are going to get the resultant value as a 0.25 amperes as the current. So we are going to get the resultant current is 0.25 amperes. So this load resistor, how much we have been got is 5 ohm. So from this step. Okay, so hope you're able to understand the problem. So this finding this Thevenin resistor is very simple. Okay, so hope you're able to understand. So the load resistor is, the load current what you require is approximately 5 ohm. So this how to solve a problem on these kind of networks.